Something is wrong out past Neptune. Astronomers keep finding icy rocks that don't behave like the rest. Short, ragged orbits. Angles that shouldn't exist if only the known planets were pulling the strings. At first, it sounds like another dry footnote in telescope logs. But this is different. This pattern refuses to be random. Why does it matter? When multiple distant objects point the same way, when their orbits line up like arrows, it's not noise. It's a fingerprint. It's a clue. And clues like this have rewritten maps of the sky before. So I called the person who has been chasing this clue for a decade. He answered with a voice that betrayed no drama, only steady conviction. "We are seeing order where we should see chaos," he said. That sentence landed like a weight. Suddenly, the scattered rocks felt like pieces of a larger machine. I tried to be skeptical. Many in the field were cautious. But the data is hard to ignore. Microhooks kept popping up, the objects cluster. Some are detached from Neptune's influence. A few orbit backward. But what happened next shocked everyone. Short line to reset pace. Here's the open loop. Everyone kept asking, what could make this happen? The simplest, most parsimonious answer is a massive, unseen object tugging at those icy bodies. A hidden planet. A ninth planet. That claim sounds dramatic. It should. But the work is methodical. Find anomalies, test alternatives, run simulations. The simulations don't just hint at something. They predict specific fingerprints. If those fingerprints match the sky, then this isn't speculation. It's evidence stacking up, piece by piece. I know that sounds like science fiction. I know you might roll your eyes. I felt the same doubt. Yet the feeling that something important is hiding in the dark is growing. And soon, we may have the means to finally see it because the whole system is quietly, insistently pointing in one direction. Something old in the story of planets, people stared up and named bright wanderers. For millennia, Mercury, Venus, Mars, Jupiter, and Saturn were the only moving lights anyone needed. They were planets, wanderers, and they felt familiar, fixed in their dances. Then a new tool changed everything. A telescope turned a dot into a moving world. William Herschel watched night after night and saw a faint object inch across the stars.
He called it George at first, a nod to King George III. The name didn't last.
The discovery did. A few decades later, Uranus drifted from its predicted path. The math didn't fit. Urbain Le Verrier used that wobble to predict an unseen body and told observers where to look. They looked. Neptune appeared almost exactly where the math said it would be, 1 degree off. And a thrill spread through the halls of science. For a while, the hunt quieted. People began to think the solar system was complete. Then anomalies returned. Pluto was discovered by chance. Later, it was demoted when better data reshaped perspective. The lesson was plain: the sky is only as complete as the instruments we bring to it. Not every search worked. Telescopes were blind in different ways. Surveys missed swaths of sky. But each time we improved our sight, the universe obliged. Build a better camera, and the missing pieces start to appear. Microhook. And that's why the odd clustering of distant objects is so striking. Astronomers today compare thousands of images, stack long exposures, and correct for survey biases, and the alignment still holds. It isn't a single telescope error. It looks like a real fingerprint. Contrast hook, short line. I remember the first paper that flagged this. Reading it felt like unlocking a code. Skeptics pushed back, asking for more data. The debate sharpened into a productive search. Gather more observations, refine models, test the predictions, and that brings us to the Kuiper Belt, where things stop making sense. I phoned the researcher who lives in this problem. He answered calm, precise, almost flat, the voice of someone used to sorting noise from signal. "We didn't want to be dramatic," he said. "But the alignment won't go away." He talks like someone narrating a crime scene. Here the tilt. Here the eccentricity. Here the cluster. Short lines cut the technical stretches, building rhythm and trust. Then he sent the plots. At first the dots read like scatter. Zoom and the scatter resolves into a pattern, distant objects pointing the same way. The reveal landed like a click curiosity. Then a cold thrill, micro hook, one object. Looks as if it was flicked out of place. He walked me through the method. Select distant Kuiper Belt objects. Correct for survey bias, run Monte Carlo tests. Ask statistics to speak. The clustering survives. It resists chance. Their simplest solution is elegant and enormous. A massive body far beyond Neptune, on a stretched tilted orbit slowly shepherding these small worlds. Tiny gravitational nudges, over eons, turn randomness into order. The math traces the choreography. Contrast hook. This is not a fireworks show. It's a patient, almost invisible hand. They then built simulations, two parallel universes, one with the hidden planet and one without. Let both run for billions of years. Without the planet, the outer system remains messy. With it, the fingerprints form again and again. Empathy anchor, watching the animations. I felt the same disbelief the team fought through, but one prediction changed everything. A steady trickle of bodies pushed inward across Neptune's path. If that inward flux exists in real survey data, the Planet 9 model moves from plausible to probable. It's small, measurable, and decisive. This was the turning point. Simulations changed everything. They built two virtual solar systems, one with the hidden planet, one without, and let time run for billions of years. If a massive body exists beyond Neptune, its gravity should leave predictable marks. If it doesn't, the outer system stays messy. The model with the planet reproduces our oddities: stretched, tilted orbits. A path that takes 10 to 15,000 years to complete. A mass about 6 times Earth's and maybe 2 to 3 times its radius. Imagine a cold super-Earth on a long, leany ellipse, microhook. And here's the kicker. It behaves unlike any familiar world, that eccentric. Inclined orbit means the planet spends most of its time far away, then swings inward slowly. Tiny tugs, applied for eons, add up. The simulated outcome is neat. Distant objects become aligned. Some get detached from Neptune, and a few even flip into backward orbits. They didn't just run the scenario once. Hundreds of variations were tested, different masses, slight orbital tilts, alternate starting conditions. The fingerprints kept showing up. Change the inputs and the same broad patterns re-emerge. That robustness is what turned a hypothesis into a serious target. Contrast hook. But these aren't vague gestures. The simulations make concrete predictions. The sky should show clusters in precise regions. A measurable fraction of objects should be crossing Neptune's path. A specific number of detached bodies should exist. Those are numbers you can test. Empathy anchor. Watching the animations, I felt the slow, patient weight of gravity. Unnerving and beautiful. Open loop. One prediction mattered most. Small, specific, decisive. If researchers find a steady trickle of objects moving inward across Neptune, then the Planet 9 idea moves from plausible to probable. Sedna is the loner dot. It rides an orbit so distant Neptune barely nudges it. How did a small world wind up that far out without gas giants doing the shoving? Neptune usually acts like a security guard. Close encounters scatter or eject. Sedna never fit that script. That makes it a detached object, one of a small set of distant outliers. Their orbits are tidy in a way that looks deliberate. Similar directions, shared tilts, and odd angles. A few even orbit backward, microhook. Some of these rocks look like they were flicked by an unseen hand. Planet 9 explains this with quiet elegance. Picture a massive world on a long, tilted path. Its gravity tugs gently over millions of years, pushing bodies outward and detaching them from Neptune's influence. Tiny pulls repeated over eons become a clear pattern. Contrast hook. This is not explosive drama. It's slow accumulation. Simulations confirm the choreography. Add the planet and the detached population appears naturally. Remove it and the pattern evaporates. Planet 9 also explains those retrograde orbits. It's inclined. Eccentric motion can flip trajectories over long timescales. Pacing reset. The catch is observational. These objects are faint and few. Telescope surveys must be corrected for bias, and discoveries depend on where and when telescopes looked. That's why early searches produced hints, but not proof. So far, 4 detached objects are confirmed, and their motions align with the model. But numbers matter. We need more data. Empathy anchor. Reading the first datasets felt like watching a mystery narrow to a single doorway. Thrilling and maddening. Open loop. There is a concrete prediction. A measurable trickle of objects pushed inward across Neptune. If observers find that flux at the predicted rate, the Planet 9 hypothesis jumps from plausible to probable. 5 sigma. That's the claim. In plain English, the team says the data reject the no Planet 9 idea with roughly a 1 in 3.5 million chance of being random. It's the kind of number that makes scientists sit up and recheck everything, but the headline needs context. The result is based on 29 objects. 29. Each is faint and hard to track. Telescopes don't sample the sky uniformly. So the analysis applies careful corrections for survey bias, essentially asking whether where we looked shaped what we found. Microhook. After bias corrections, the agreement with the Planet 9 simulation remained. That persistence matters. The researchers ran many tests, Simulated surveys, injected fake objects, varied assumptions. The clustering survived. Statistically, the planet model outperforms the no-planet model by a margin large enough to justify 5 sigma language. Contrast hook. That sounds definitive, and yet scientists are rightly cautious. Small numbers are fragile. A few new detections, an orbit revision, or an overlooked bias could shift conclusions. The team is explicit about limits. More data is essential before crowning a discovery. Empathy, anchor. I felt both excitement and restraint reading their paper. Hopeful but aware of the pitfalls. Open dash loop. So how do we get more data, fast? Vera Rubin is the answer. Its wide, rapid, deep survey will find many more distant objects, filling the blind spots and solidifying bias corrections. If Rubin measures the predicted inward flux, a few % of distant objects crossing Neptune's path rather than a tiny fraction, the statistical case will harden quickly, pacing reset, for now. 5 sigma is our strongest signpost, bold, persuasive, but not yet the final word. Rubin will put it to the test. I visited the Vera Rubin Observatory. It feels like a cathedral for stargazers. The dome is a hush of steel and glass. The camera inside sits like a patient eye. Up close, the scale is hard to hold in a single breath. You walk into a room built to stare for decades. Rubin's mirror is 8.4 meters. The camera is the largest ever made, a tiled sea of sensors the size of a small car. Short line, it gathers light like a deep well gathers rain. Microhook. And it photographs the whole visible sky every few nights. That's the game changer. Previous telescopes took years to sweep wide and deep. Rubin does it fast. It will image the visible sky to unmatched depth every 3 nights, building a 10-year time-lapse of the heavens. That cadence turns snapshots into motion pictures, revealing slow motions that once hid in the noise. Contrast hook. If earlier surveys were hammers looking for nails, Rubin is a high-speed camera catching the tiniest flicks in slow motion. Standing under that camera, the math began to feel inevitable. You imagine simulations running in reverse, tiny tugs amplified into patterns, now finally visible. Empathy anchor. I felt a tight, nervous optimism, the kind that makes you want to watch the sky all night. Rubin will flood astronomers with objects. The statistics will shift from awkward anecdotes to clean totals. Biases that haunt small samples will melt under a torrent of detections. Simple numbers will either confirm the inward flux predicted by Planet 9, or force us to write new theories. Pacing reset. There is a timetable. Within a year or two, Rubin's early survey should provide decisive statistics. It won't necessarily deliver a dramatic photograph on day 1, but the data will reveal whether the fingerprints persist at scale. For planet hunters, that's the moment that matters. Open loop. And if Rubin shows the flux, everything changes. If Rubin fails to find the signal, the alternatives get darker and weirder. First, observational bias. Maybe our telescopes and surveys painted an illusion. Short line. It's boring but possible. Astronomers simulate survey footprints, inject fake objects, and ask whether selection effects could create the clustering. In several tests, bias explains parts of the pattern, but not all. The alignment keeps reappearing. Microhook. So we look further. Next, Neptune's migration. 4 billion years ago, the giants shuffled. That chaos could have trapped and sculpted distant orbits. It's a slow, plausible explanation that needs to reproduce Rubin's precise fingerprints to stick. Contrast hook. Then the speculative options. A primordial black hole, with planetary mass, but an almost invisible size, would tug the same way yet be undetectable by light. It neatly sidesteps the why not seen problem. But its discovery would rewrite cosmology. And it's a very bold claim. Pacing reset? Or consider a captured rogue. A world stolen from a sibling star during the sun's messy youth. The idea is cinematic. An exoplanet drifting into our neighborhood and staying eccentric and lonely. It's possible in dense star clusters. And it would change how we see planetary formation and migration. Empathy anchor. Imagining a stolen planet makes the solar system feel like a messy, living neighborhood rather than a tidy family portrait. Open loop. One edge case explanation remains that would append everything, but it needs Rubin's data to be taken seriously. Short line. Whatever the outcome, these alternatives are testable. Rubin will expand the sample, close survey gaps, and force each story to stand or fall. The next chapters won't be decided by speculation. They'll be written in data. I put a small bet on Rubin, and I'm not alone. The logic is tidy. Fingerprints in the outer system. A measurable inward flux. A simulation that reproduces odd orbits. It stacks, but science is not betting. It's testing. The thrill isn't the wager, it's the possibility of a clean, undeniable answer. Microhook. Imagine checking morning headlines and seeing Planet 9 confirmed. The path is practical. More objects. Better orbits. Less bias. Rubin will deliver thousands of transients and many new distant Kuiper Belt objects. Those numbers turn fragile patterns into solid statistics. An inward flux that is now a whisper will either roar or vanish. Contrast hook. If it roars, everything rearranges. If it vanishes, we rewrite the history books differently. I asked the researchers what they'd do if Rubin shows a clear signal. Short answer: celebrate, then get to work. Longer: refine models, point other telescopes, plan targeted observations, start thinking about missions. A new planet raises new, urgent questions: composition, origin, moons. Early disruption, empathy anchor. When I picture that first confirmed orbit, I feel a child's awe, the small thing that becomes a real place. Timelines matter. Rubin's early survey should produce decisive statistics within a year or two. That doesn't ensure an instant photo. The planet might remain faint, but the statistical case will either strengthen sharply or crumble. Pacing reset. If Rubin finds nothing, the field pivots. Observers will hunt stellar encounter signatures, refine migration models, run infrared searches for a cold body, or consider non-luminous mass like a primordial black hole. Harder paths, but not impossible. Open loop. One unexpected discovery could erupt from the data, something no model predicted. For now, watch the sky. Count the objects, let the numbers speak. The outer solar system is whispering. Rubin will make it sing. Imagine the announcement: a newsroom lights up. Scientists cluster around screens. A live feed from a telescope shows a faint, steady pinprick. After months of stacking, it's no longer noise but a tracked orbit. Short line: the sky just added a new member. The name debate erupts. Persephone or Bowie? Naming is small next to the change in our map. Textbooks rewrite. Kids learn a planet no human had seen. Microhook. Imagine pointing at that dot and knowing it's real. Teams shift from argument to action. Pin the orbit. Measure brightness and color. Infrared searches probe for heat. Spectra hint at ice, rock, or something stranger. Missions once fanciful, probes, long-range scouts, become real options. Contrast hook. Bureaucratic spreadsheets. Meet midnight wonder. Cultural ripples follow. Poets, forums, classrooms all find a new line. Astronomers answer blunt public questions. Does it have moons? Could it affect us? Answers are cautious and precise. Empathy anchor. I picture the tired observers, whose quiet nights turned into morning joy, then the science marathon begins. Was it born here or stolen from another star? Composition, orbit, satellites. Each clue shapes the origin story. Observations will confirm or complicate the narrative. Open loop. The big choice: launch a probe, now or study longer. Short line: a probe is decades of planning. Waiting buys better instruments. Either path reshapes priorities and deepens questions. Pacing reset. Discovery forces humility. And curiosity. Our map was incomplete. If one outsider exists, others might. It invites new astronomers and new missions. Final. Microhook. The sky kept a secret. And we are about to read the first page. One last short sentence. Rubin and partner telescopes will keep watching. Within a few years, the whisper will become an answer, confirmation, refutation, or a stranger twist. For now, listen, the night is telling us something new.